Hello everyone, my name is Jennifer Dennedy, and today I'll be presenting my senior capstone project titled Wildfire Impacts on Water Resources in the Pecos Watershed of New Mexico, Climate, Hydrology, and Resilience in an Arid Environment. I chose the Pecos region because it combines several environmental issues that are becoming increasingly important throughout the American Southwest. The area is experiencing rising temperatures, prolonged drought, increased wildfire risks, and growing pressures on limited water resources. I have also completed previous research projects focused on the Pecos region, including a wildfire resiliency report and a climate action plan, which helped provide the foundation for this capstone. Through this project, I wanted to better understand how climate change, wildfire, and hydrology are interconnected and how those relationships affect water resources in an arid environment. How do climate, hydrology, and human activities influence wildfire risk in the Pecos watershed, and how do wildfires affect water resources in this arid environment? I wanted to move beyond looking at wildfires simply as a forest management issue. Instead, I focused on understanding how wildfire affects watershed processes and water availability. This is especially important in New Mexico because water is already a limited resource. When wildfires occur, they can increase erosion, reduce water quality, alter stream flow patterns, and create long-term impacts for both ecosystems and communities. This project has four primary objectives. First, I examine the wildfire risk within the Pecos watershed. Second, I analyze the climate and hydrologic factors that contribute to wildfire occurrences. Third, I evaluated how wildfires affect water resources, including runoff, erosion, flooding, and water quality. Finally, I identified management strategies that can improve both wildfire resilience and long-term water resource sustainability. Together, these objectives connect concepts from climatology, hydrology, environmental science, and water resource management. The focus area of this project is in the Pecos watershed in northern New Mexico. The watershed is located within the Sangre de Cristo Mountains and includes portions of the Santa Fe National Forest. The Pecos River is an important water resource that supports agriculture, wildlife habitats, recreation, and local communities. The area is also classified as a Wildland-Urban Interface, or WUI, which means homes and infrastructures are located near or within fire-prone forests and vegetation. This combination of forested watersheds, valuable water resources, and increasing wildfire risk make the Pecos region an excellent case study. To understand wildfire risk, we first need to understand why New Mexico is considered an arid to semi-arid environment. Arid regions receive relatively little precipitation while experiencing high rates of evaporation. In many parts of New Mexico, more water is lost through evapotranspiration than is gained through precipitation. Several factors contribute to these conditions, including New Mexico's location within the southwestern dry belt, limited annual precipitation, high solar radiation, and mountain rain shadow effects. These conditions create water scarcity and make vegetation more susceptible to drought stress, increasing the likelihood of wildfires. This slide explains one of the major controls on the global distribution of deserts and arid lands. Warm air rises near the equator, where solar energy is greatest. As the air rises, it cools and moves towards higher latitudes. Eventually, that air descends around 30 degrees latitude in both hemispheres. This circulation pattern is called the Hadley cell. As air descends, it becomes warmer and drier, creating high-pressure systems that suppress cloud formation and precipitation. New Mexico lies within this subtropical dry zone, which helps explain why much of Southwest experiences arid conditions, frequent droughts, and elevated wildfire risk. Weather and climate are closely related but represent different timescales. Weather refers to short-term atmospheric conditions such as daily temperatures, humidity, wind, and precipitation. Climate, on the other hand, refers to long-term trends and averages observed over decades. Wildfire behavior can change dramatically based on daily weather conditions, but long-term climate trends determine overall wildfire risk. In New Mexico, climate change is contributing to warmer temperatures, earlier snowmelt, more frequent droughts, and longer fire seasons, all which increase wildfire vulnerability. The Pecos Mountains have historically maintained a cooler climate because of their higher elevation. However, temperatures throughout New Mexico have been steadily increasing. This warming affects both wildfire and water resources. Higher temperatures increase evaporation rates, dry vegetation more quickly, and place additional stress on forest. One important consequence is earlier snowmelt. Snow that traditionally remained in the mountains until late spring is melting sooner, reducing water availability later in the year when demand is often at its highest. The Pecos region relies on two major sources of precipitation: winter snowfall and summer monsoon storms. Historically, these precipitation patterns help maintain stream flow throughout the year. However, climate change is increasing variability. We are seeing longer dry periods interrupted by more intense precipitation events. This creates uncertainty for water resource management because communities, ecosystems, and agriculture all depend on reliable water supplies. Drought is one of the most significant environmental challenges facing New Mexico. Drought conditions are evaluated using precipitation trends, river flows, reservoir levels, snowpack measurements, and seasonal forecasts. When drought persists, soil moisture decreases, vegetation becomes stressed, and wildfire risk increase substantially. Long-term drought can also contribute to insect outbreaks, tree mortality, and declining watershed health. Climate conditions in New Mexico are influenced by large-scale ocean and atmospheric interactions. One important pattern is the El Niño Southern Oscillation, or ENSO. During El Niño events, New Mexico often experiences wetter winters and increased snowpack. During La Niña events, conditions are generally drier, which increases drought severity and wildfire risk. Understanding ENSO helps scientists and land managers better anticipate future climate and wildfire conditions. Hydrology is the study of how water moves through the environment. The Pecos watershed functions as a complex system involving precipitation, snowpack storage, infiltration, groundwater recharge, stream flow, and evapotranspiration. Because water is limited in an air environment, even small changes in climate or vegetation can significantly affect how much water is available throughout the watershed. This makes hydrology a critical component of understanding wildfire impacts. Now, this slide here highlights one of the most important hydrologic concepts in the Southwest. Mountain snowpack acts as a natural reservoir by storing water during winter and gradually releasing it during the spring snowmelt. This process helps maintain stream flow, recharge groundwater, support ecosystems, and provide water for communities and agriculture. Climate change is disrupting this system by causing earlier snowmelt and reducing overall snowpack accumulation. As a result, less water may be available during the late summer months when demand is often at its highest. Historically, the Pecos region experienced frequent yet low-intensity fires, typically occurring every 5 to 30 years. These fires played an important ecological role by reducing fuel accumulation and maintaining healthy forest conditions. The result was a more diverse landscape with a lower risk of large, high-severity wildfires. However, decades of fire suppression interrupted these natural processes, allowing fuels to accumulate and increasing wildfire severity. Long before modern fire management agencies existed, indigenous people used fire as a stewardship tool. Cultural burning was used to manage vegetation, improve wildlife habitats, maintain travel corridors, and support important plant resources. These practices helped create resilient landscapes and reduce fuel accumulation. Today, indigenous fire stewardship is increasingly recognized as a valuable approach that can complement modern wildfire management strategies. This fire serves as a primary case study for my project. The Hermit's Peak Calf Canyon fire became the largest wildfire in New Mexico history and affected large portions of the upper Pecos watershed. Approximately 40,150 acres within the watershed burned, and about 34% experienced high-severity fire. High-severity burns often resulted in complete tree mortality and leave soils highly vulnerable to erosion, flooding, and water quality degradation. The map shown on this slide was created by me using ArcGIS Pro as part of my earlier wildfire resiliency research on the Pecos region. I used GIS data to visualize the fire perimeter and its relationship to the Pecos watershed and surrounding communities. Creating this map helped me better understand the spatial extent of the wildfire and how closely wildfire impacts are connected to critical water resources in the northern New Mexico region. This project also demonstrates the value of GIS as a tool for analyzing wildfire impacts, watershed vulnerability, and environmental planning. This event demonstrated how wildfires can quickly transition from an ecological disturbance to a major water resource issue, affecting forests, watersheds, and downstream communities. Now, this is really the central slide of my presentation. Before wildfire, vegetation intercepts rainfall. Roots stabilize soil, and healthy soils promote infiltration and groundwater recharge. After a severe wildfire, many of these protective functions are lost. Runoff increases, flash flooding becomes more likely, and large amounts of sediment can be transported into streams and rivers. Water quality often declines because ash, nutrients, and sediment enter aquatic systems. These impacts can persist for years and affect drinking water supplies, reservoirs, aquatic habitats, and downstream communities. Water use in the western United States has always been closely tied to population growth and development. Although the Pecos itself is a relatively small community, the Pecos River supports agriculture, municipal water supplies, recreation, and ecosystem health throughout the region. As populations continue to grow throughout the Southwest, demand for limited water resources increases. This makes protecting watersheds from wildfires and other climate-related impacts increasingly important. Addressing wildfire risk requires a combination of ecological, engineering, and community-based solutions. These include forest thinning, prescribed burning, watershed protection, sustainable land use planning, renewable energy development, and community preparedness. Indigenous stewardship practices also provide valuable lessons for restoring healthy fire regimes. Ultimately, resilience requires collaboration among scientists, land managers, tribal governments, local communities, and policymakers. Climate change does not affect everyone equally. Rural communities, indigenous populations, and lower-income residents often have fewer resources available to recover from wildfire damage, water shortages, or infrastructure disruptions. For that reason, climate adaptation and wildfire planning must also consider social vulnerability. Building resilience means protecting both natural systems and other people who depend on them. This project demonstrates the climate, wildfire, hydrology, and water resources that are deeply interconnected. The Pecos watershed provides a clear example of how climate change can influence wildfire risk and alter watershed processes that communities depend on. One of the biggest takeaways from this research is that wildfires are not simply a forest management issue. It is also a climate issue, a hydrology issue, a water resource issue, and an environmental justice issue. Protecting the future of the Pecos watershed will require integrated management approaches that address all of these challenges together. Thank you all for your time, and I really hope you enjoy my senior capstone presentation.